These are the frequently asked homework questions from section 2-3 for Algebra 2. Number 54 would be the first one, and it's just like the literal equations that we had in chapter 1. It just gets some people all weirded out to have that many variables in one problem. So we have negative ax plus by equals negative c, and we are to solve this one for y, because it says find the slope and y-intercept of each line. The easiest way to do that is if we have y equals mx plus b. So I take a look at this, and I realize, well, that means I need to move this x term over, and I'm going to have to get rid of this b that's sitting right here. So that's what I'm going to do. I'm going to go ahead and add ax to both sides. Now notice I'm putting the x term in front because, again, I want to do y equals mx plus b. And I'm going to go ahead and divide both sides by b. So y is all by itself now, which is exactly what we wanted. And then, since I can't actually do the division here, and I want this in that slope-intercept form, what I'm going to do is write it as a over b x minus c over b, so that I can answer the question, which was, what's the slope and what's the y-intercept of each line? And since I now have those separated, I can see what they are. The slope is capital A over capital B, and the y-intercept is negative capital C over capital B. And again, like I said, that usually just bothers some people because of all the variables involved. You can either write y-intercept, or you can actually write the coordinates, because if it's the y-intercept, it's going to be 0 right and left, and then negative c over b for that y-intercept. Either one of those will work. Then on the next page here, I have the equation d equals 4 minus 1/15 t represents distance from home, and d for each minute you walk t. A says, if you graph this equation, what would the slope represent? And explain. Well, the first thing I thought is, this is kind of backwards. You know, I can see that t is my independent variable, so I really should write it like that. But they are actually trying to help me by having it backwards, and we'll see why in just a little bit. So if I graph this equation and I think about what's going on, what's happening is you're walking towards home. Now, how do I know that? Because you're starting with the distance of 4, and you are subtracting as you move forward with time. So as I look at this and I'm thinking, well, the whole equation has to be about distance, because this is distance. Well, that means this little chunk right here has to be distance. And how can two things give you distance? Well, only if they're rate times time. So when we graph this equation, our slope of negative 1/15 is actually the rate or speed of walking. And again, you just see that it's subtracting away from a total there. And then for part B, it says, are you walking towards or away from your home? Well, remember, I already talked about that when I went through part A. I know I have to be walking towards home. Because of the subtraction in here, that indicates that I'm getting closer and closer to 0, would be that distance from home. So are you walking towards or away? Towards. And explain the distance to home is decreasing as t, well, we'll just put as t since it's time, as time gets longer, bigger. So with the passing of more time, what's really happening is you're going farther, and the distance is shortening and getting closer and closer to 0. So that's the reason that we know we're going towards. All right, now Number 58, we have a classmate that says that the graph of 3y minus 2x equals 5 has a slope of 2. What mistake did he make? Well, what you want to do is do it yourself and see what the slope is. So we would add 2x to both sides. And right now we can see exactly what they did. They did not divide by 3. I mean, that's the only reason they could possibly think that a 2 is the slope there. So they forgot to solve for y by dividing by 3. And that's what we need to write down. They forgot to divide by 3. As that one step before it, we can see where they'd have that slope of 2. Then the last one here, and this one I'm just going to do because it's fun. It has a lot of different fractions in there. I know you guys probably aren't going to think it's fun, but I do. And you know, whenever you're going to deal with slope, we know there's subtraction involved, and you see fractions, so you should be thinking right away, all right, if I'm going to do anything with fractions, I'm going to need a common denominator. So first things first, I would go ahead and change these to common denominators, and with 2 and 3, the least common denominator would be 6. So we're going to multiply each of these fractions on the top and the bottom by 3. So we will have 9 6 and negative 3 6 for the first point. And then this second set, we're going to multiply the top and the bottom by 2 to get that common denominator. So negative 4 6 and 2 6. Now, as I do all of the math that I need to do for slope, it's going to be a little easier. So slope is change in y over change in x. So what I need to do is just decide on a direction and go with it. So I'm going to do 2 6 minus negative 3 6. All of that divided by negative 4 6 minus 9 6. So on the top I have minus a negative, which is actually addition. And that will give me 5 6, because 2 6 minus a negative 3 6 is 2 6 plus 3 6, which is 5 6. And then on the bottom, I have a negative 4 6 minus 9 6, which is a negative 13 6. And now I have a fraction being divided by a fraction, and we know we don't do that. We multiply by the reciprocal. And at this point, everybody should see, hey, I can do a little cross-reducing. That's 6 will cancel right out of there. And I don't want to forget about my little negative symbol here. So negative 5/13. So first step there is just to think ahead to the fact that you're going to be dealing with fractions. And whenever you're dealing with fractions, you need a common denominator to add or subtract. And that just makes it a lot easier once you realize that. That is it for this section.